now that you've made it through your first benchmark week of the year, we are going to continue content. Today, I'm going to introduce you to the rational root theorem. We use it to determine the potential rational roots of any polynomial. Okay, so let's unpack that. Potential means they're not always going to happen. Rational roots mean it's not going to cover I or square roots. To find the potential roots of a polynomial, we're going to divide the factors of the constant by the factors of the leading coefficient. I am going to take it a little bit further and we're going to find all of the roots. And if that doesn't make all that much sense today, that's okay. We're going to regroup and look at this in our next class. So our very first example, I want you to determine or find the potential roots of this problem. That's what I want to make sure that you leave here today feeling comfortable with. And I'm going to go ahead and find all the real roots. So the polynomial we want to look at today, or the first one, is x cubed plus 4x squared minus 29x plus 24. First, let's try grouping. So when we group, we're going to take an x squared out and a negative 1 out. Notice that my binomials this time don't match. Okay, so in our last unit, I told you if they don't match, that tells you you've done something wrong. That's not the case now. Now the case is going to tell you that you have to do something different. So I'm going to look at my constant, which is 24, and think of all of the numbers that multiply together to give me 24. I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So notice that I kind of went in order. I did 1, always start with 1, and then I did 2, and then I divided by 3, and then I divided by 4. And then once I got to the 6, I knew that 7 wouldn't divide evenly, and 8 does, but I already wrote it down. Now we're going to divide by our leading coefficient, which is just 1. And anything divided by 1 is itself. So when I go to write all of these out, I've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Notice that every single potential has a plus or minus, and when I wrote them in order. You don't have to, though. You could have left it as what I did in the fraction, since it was over 1, and just boxed your answer, and that would be fine. Now, here's what we're going to do to find our answer. My promise to you is that the first two integers in either positive or negative will work. So now I'm going to use what I know about synthetic division. So I'm going to try for 1 first. So I'm going to put 1 in my box, and then I've got 1, 4, negative 29, and 24, which are the coefficients from the problem. Then I'm going to go through all of this synthetic piece. When I do that, I'm going to get a remainder of 0. When you get a remainder of 0, that tells you it's a root, because it divides in evenly. They mean the same thing. So now I'm going to take my resulting polynomial, which is x squared plus 5x minus 24, and factor it. So I need two numbers that multiply together to give me negative 24 and add to give me 5. That's 8 and negative 3. So I've got x plus 8, x minus 3. Now, when you take that x plus 8 out of the parentheses, the sign's going to change. So I'm going to get negative 8 and positive 3. Notice that I have 3 answers, just like the leading degree. So my answers are 1, negative 8, and 3 in any order. Remember, today, I'm not really looking that you can find those zeros. I just want you to make sure you can find the potentials and you understand how to find the potentials. But, let's try it again. This time we're going to have 2x cubed minus 5x squared plus x plus 2 equals 0. I still want you getting in the habit to check to see if grouping works, because sometimes it does work, and if it does, it'll save you a lot of time. This time, though, my binomials don't match. So then I've got to go through the rational root theorem. So first I'm going to take a look at the constant, which is 2. 2 is prime, so the only two numbers that multiply together to give me 2 are 1 and 2. Then I'm going to look at the leading coefficient, which is also 2. So two numbers that multiply together to give me 2 again are 1 and 2. So now I'm going to have to separate my division. So when I go to do this, I'm going to have to do 1 divided by 1, which is 1, and 2 divided by 1, which is 2. Then I'm going to do 1 divided by 2, which is 1/2, and 2 divided by 2, which is 1, but I already wrote it, so I don't need it there. So remember, my promise to you whenever we get this next class is that the lowest two, positive or negative, will work. And if they don't work, you've done something wrong. So let's try positive 1. It typically is the one I always try first. So when I go through synthetic division this time, I get a remainder of, what do you know? 0. So that tells me that 1 is a root. Okay, so now let's figure out my resulting polynomial. So I've got 2x squared minus 3x minus 2. If you wanted to, you could do rational root theorem again, but I'm going to go back through x method 2.0. So I have to do 2 times negative 2, which is negative 4, and my b is negative 3. So I need two numbers that multiply together to give me negative 4 and add to give me negative 3. So negative 4 and negative 1. Substitute them back in to get yourself a 4-term polynomial. Now group. The first group has a 2x in common, so I'm going to take that out. My second group has a 1 in common, so take that out. Notice this time the binomials match. They're both x minus 1. That's what tells you that this method works. So now I've got x minus 2 times 2x plus 1. So when I take those out of the binomials, that's going to end up giving me positive 2 and negative 1/2. Since the degree of this problem was 3, I'm looking for 3 answers. So my 3 answers are 1 from the synthetic division, 2, and negative 1/2. Remember, just reiterating one more time, today I'm not really all that concerned that you can find all the zeros. What I want you to feel comfortable with is that you can find the potentials. We'll worry about starting to find all zeros next class. However, in your practice, I go through it all because I think you can do it. So if you want to go ahead and give it a shot, I will absolutely love it.